So today's lecture is regarding databases. This is the final chapter of the course. I think it rounds out things pretty well because, like, if you remember, in chapter 1, we did some basically introductory programming. Chapter 2, we got more into how to practically program and how sort of projects are created and stuff in object-oriented programming. Then we did sort of software development generally, like how software developers actually work, what they do, what they use. Then web developments. So that was obviously developing websites, which is one very important aspect of software development. Then we covered desktop applications, obviously another important aspect, and now is databases. So basically the only thing this course doesn't touch on is mobile app development. Although you'll find a lot of common functionality between mobile apps and desktop apps. So it's like quite a similar idea where everything is done with events. But yeah, so now we're on to the last thing, databases, how we store and work with data. So we did cover data structures, but obviously databases, data structures are very different. So data structures is kind of how we store this information inside the computer's memory. But databases is how we store it at rest. If we're working with a large amount of data, maybe even too much to fit inside the computer's memory, we're working with it over a long period of time. So we need it after our program shuts down or after our program goes to sleep or something. That's when databases come in handy. Okay, so yeah, today's lecture will be very theoretical. Next week, we'll get into how to actually program with databases, but especially when starting to learn databases, there's a lot of terminology that you need to learn, a lot of words, a lot of new words that you guys need to understand before we can start working with them properly, okay? So yeah, don't worry, we will program together, yeah, you guys will program with me next week, next weekend. But today will be more theoretical. But yeah, hopefully we can work through today's lecture quite smoothly. Oh, and then also after this, I'm going to give you guys an interactive, it's like almost like an online, it's kind of gamified. So it's almost like a game or a challenge, a series of challenges that will teach you. So there will be 3 of them. The first one will be on today's content, the next one will be on next week's content, and the next one will be on the last week's content. So this is our 3rd last lecture, probably. But yeah, let's just get into it and see how it goes. So the first thing we need to learn about databases is obviously what a database is. So a database is an organized collection of interrelated data. So not too difficult to understand. So we know what like a collection is. It's just a group of data. And we've got like, so interrelated just means that the data is, there's a reason, let's put it this way. There's a reason why all of the data would go in one database, right? Like as opposed to 2 databases. If you had a, for example, if you had a library database, you would have authors, you would have books, you would have publishers, and you would have customers, right? And all of that data is interrelated, right? The customers buy the books, the authors write the books, the publishers publish the books, right? So it's interrelated data. You wouldn't store like a like books and cars in one database, right? Because books and cars aren't really related to one another. Fair enough. I can see that there would be a devil's advocate saying, what if it's a book about a car? But you get what I mean, I think. Okay. Cool. And yeah, the next thing is that data, what data is unprocessed information. Okay, unprocessed information in a way. So like an information is processed data. So like data is the raw data. Okay, raw data is what you might call it. It's like literally just facts and figures. They haven't been interpreted or used yet, but you guys will see some examples of data later, and it just makes sense. Okay. So in general, people don't really use like a database that's not specific enough. Like a database is not really a we use something more specific than that, something more powerful than that, called a relational database. A relational database. So a relational database is also just an organized collection of interrelated data. What makes a relational database different from a database is how the data is organized. We call a database a relational database if the data is organized according to these three things. Okay, there's three things. We've got, let me see, does drawing work on this? I think it does work, but you have to erase it afterwards, which is fine. Wait, where is it? Oh, yeah, okay. If it's organized according to these three things, okay? So the three things are attributes, attributes, relationships, and entities, okay? Attributes, relationships, and entities. So those look like three new words, but don't worry, guys. You actually already know what these three things are. So it won't be too bad for us to learn these three concepts because you already know what they are. But if a database, if the data in a database is organized according to attributes, relationships, and entities, then we call it a relational database. One piece of terminology, it's fairly self-explanatory based on the name. But the thing that we use to manage our database and to create it and to back it up and to access it and to store it is called a DBMS, a database management system. And there's lots of different database management systems. If a database management system is designed to work with relational databases, then we call it a relational database management system. But in general, nowadays, DBMS is enough because almost all databases are relational databases. So it's you don't have to get more specific than that. Cool. All right. So there are a bunch of steps for designing a relational database, and here they are. It looks like a lot, so there's 6 of them, right? But really, these center 4 steps are all like one thing, basically. These center 4 steps that I've got this bar around they're all handled by one particular thing, okay? So really, it's almost as if there's 3 steps because you do one thing to handle these center 4 steps. But the flow also makes sense. So when we want to design a database, the first thing we need to do is create a mission statement. I think this is a pretty silly one for them to put because, like, obviously, basically all this first step is saying is you need to know why you're creating a database, right? Like you wouldn't just randomly create one. So you need to know why you're doing it. What's the purpose of it? So yeah, what are we doing? The next thing is to say you need to determine which data needs to be stored there, okay? And how much of that data, because those decisions will affect like how much space you need, how fast it needs to be, all of those kinds of things, okay? You need to divide the data that you're storing into tables and columns because all a database is, guys, you guys know what a table is, right? I know all of you know what a table is. Yeah, so you guys know what a table is. All a database is really is a set of tables, a bunch of tables, a bunch of rows, a bunch of columns, okay? It's just, that's all a database really is, and you'll see that now. We have to choose what's called a primary key. The primary key is the column that uniquely identifies each row. Again, it'll make more sense. But I can give you a simple example. Let's say we had a database that was storing all of the South African citizens. Okay, so every South African citizen. So we've got this table, and it's got every single South African citizen in it. And we've got a bunch of details, right? We've got a bunch of columns. For example, we have the South African's name, the South African's surname, the South African's birthday, the South African's age, the South African's province that they live in. So we have all of these columns, and each row is one South African, right? So on the first row, we might have Chris. On the second row, we might have me. On the third row, we might have Yusuf. On the fourth row, we might have everyone who's absent. I'm just going through the list of participants because there's only the 3 of us. So we would go through this list. Each row would be a person, right? And you can imagine in that situation, what would we use, guys? So I'm actually asking you this as a question. what would we use to uniquely identify each South African? Either of you have any ideas? What would we use to uniquely identify each South African? Wait, you guys are in grade 8. I don't actually, oh, you wouldn't actually have the thing that we use to uniquely identify each South African, I don't think. Interestingly enough. But do either of you have any ideas? What would we use if we had this database of all of the South Africans? What column would we use? Like, would we use their name, their province? Is there a specific thing that you can guess? Okay, maybe when we, an ID is a good one. Yeah, an ID is a good one. Name. So the problem with that, Yusuf, is that there would be lots of South Africans with the same name, right? So you can't use the name to uniquely identify them. So this is why we need an ID number, right? An ID number. Okay, cool. So an ID number in that table of South Africans, the ID number would be the primary key. That would be what we call the primary key. Then we have to identify relationships between our data. So for example, what I did earlier with the library example, the relationships between the data, right? Like we've got a bunch of data on books. We've got a bunch of data on authors. The relationship between authors and books is that authors write books. Okay, so that's a relationship, right? That's the relationship between the different parts of our data. If we had a database of provinces or municipalities, we had a database of provinces, for example, and we had a database of South Africans, the relationship between our data would be that South Africans live in provinces. Okay, so we have to identify all the relationships between our data, and then we have to do this thing called normalize the database, but we'll discuss that later. That's a whole big topic in itself. This last step is probably the most difficult bit. But yeah, like I said, so the first step, very easy, and these center 4 steps are what we'll talk about. Okay, so these center 4 steps are all handled by one thing, like I said. And the thing that handles these center 4 steps for you is called entity relation modeling. So basically, you need to create a thing called an entity relationship diagram for your database, an entity relationship diagram, and that will handle these center 4 steps. So basically, we're going to draw a picture, and it will handle these center 4 steps for us. Okay. And it's quite useful to picture a database like this, because I actually recently had to create like a fairly complicated database, and it was making me very anxious. And so what I did was I just drew up an entity relationship diagram, and then you have a much better grasp. You have a much better understanding of what it is that you need to do. Okay. So yeah, this is how that's done. It's quite a simple thing, actually. They're not too bad. Okay. So relational databases organize data, okay, by defining, and you can see what's in bold, the entities, the attributes, and the relationships between the entities. Okay, so like we said, a relational database is a database that organizes the data according to these 3 things. But you guys obviously don't yet know what those 3 things are, so we're just going to discuss them now. Okay, so cool. What are these 3 things? So an entity, okay, an entity, what we call an entity, is a construct that represents a physical object or concept. Entities are named for the nouns that they represent. So, for example, we could have a book, or like a book table, a customer table, a publisher table, or an order table. Some other examples, you might have car, okay? A car would be an entity. Or like a car table, okay? Because it can be a concept as well, okay? A province, country, all of these things are entities. Now, guys, when you hear this, so you guys have seen a concept before that is very similar to this concept of an entity. So it's also always represented by a noun. But let me ask you this. If we were in C# and we wanted to create our own type called product, okay? Like that's an idea, right? It's a concept, a product, okay? How would we represent a product inside C#? guys? Like what structure would we use to create that? Do either of you have any ideas? What structure have we seen in C# that can be used to represent that? Maybe a little bit of a difficult question because we're connecting two slightly different concepts, but they are very closely related. So let me ask you this way. Whenever we've run into something where we want to create our own type, like particularly if we think about chapter 2, where there's some idea, some concept that we want to represent in C#. It's built up of a lot of different things. It's like a complex type. What do we create to represent that type inside C#? In fact, so in entity relationship diagrams, we represent entities with rectangles. Okay, now this is totally a coincidence, but we have actually created a rectangle inside C#. Do you guys remember what structure we used to create that? What structure inside C# did we use to create the concept of a rectangle? Do either of you remember? So we gave it like a length, a width. We were basically creating our own type back in chapter 2. Ooh, we don't remember. How do you create your own type inside C#? So if we wanted a type that has a length, a width, a way to calculate its area, maybe if we were creating another thing that maybe a person, how would we represent a person inside C#? With like a hair color, a height, a weight, how would we represent that? Do you guys remember? What structure do we use? Okay, we're at a loss. Guys, it's called a class. Okay, we use a class to represent those things. A class. And a class is very similar to an entity. Okay, so classes and entities are very closely related. We also have inside relational databases things called attributes, interface. Interface is close, Yusuf. So yeah, that is, but yeah, class is what I was looking for. Class and entity, very closely related. Okay. But yeah, interface, close, yeah. So we have our entities. They're very closely related to classes. They just represent physical objects or concepts. So a book, you could create a book class, but you could also create a book entity, okay? Customer entity, okay? So you could create all of these things, okay? And attributes. So each just like in C#, when we create a class, right? Our class had different properties in it, right? So for example, the person class would have a hair color, a weight, and a height, right? And a bunch of other things. A rectangle class would have a length and a width. Those interfaces we created had like a method for attacking, right? And a name, okay? So our classes inside C# have a bunch of properties. And just like that, in relational databases, each entity has a bunch of attributes. So an entity having attributes is the same as a class having properties, okay? So the attributes are just the properties that make up or define an entity. Okay, so for example, if we had an entity, South African, okay, that South African entity would have multiple attributes, right? Like a first name, a surname, an ID number, a province, all of these kinds of things, okay? Cool. The last thing in relational database is the relationship. And that we've already discussed relationship a little bit, right? Like authors publish books, South Africans live in provinces, all of those kinds of relationships, right? Publisher releases book, customer places order. So places is the relationship, releases is the relationship. So that's the association between different entities, okay? And it's usually a verb, okay? It's a verb. So these are represented inside what we call entity relationship diagrams. The entity is a rectangle, the attributes are ellipses, and the relationship is a diamond, okay? And it would look something like this. So here we've got an entity relationship diagram, okay? We've got an entity relationship diagram. So guys, we have two entities. So I want you guys to tell me. We have two entities in this entity relationship diagram. What are the names of our two entities? What are the names of the two entities inside this entity relationship diagram? You guys tell me. Publisher and book, exactly. Okay, so publisher and book are the names of the two entities inside this entity relationship diagram. Okay, so we've got publisher on the left here and book on the right. Okay, so how do we know that they're the entities? Well, number one, just where they are and the concept they define, right? Both of them are constructs. They're physical objects or concepts, and they're nouns. Okay, they're nouns. So publisher, book, those are our entities. You can see that they are rectangles. Okay, so in an entity relationship diagram, entities are represented with rectangles. Okay, next I'll ask you another question. How many attributes are there in this entity relationship diagram? How many attributes total? Okay, 6, exactly, yes. Okay, we've got publishers have an ID, a name, and a city. Okay, they have an ID, a name, and a city. Books have an ISBN number, a title, and an author. Okay, so each of them have their three attributes. ISBN is just like an ID number for a book. Okay. And then the relationship between publisher and book is that the publisher releases a book. Okay, there's one other thing that I need to explain to you guys here in this diagram. So you can see that on the left here, by the publisher, there's this 1. There's a 1. And on the right, by the book, there's an N. An N. Okay. What that means is the 1 means 1 and the N means many. Okay, because there's N number. There's some number of books. That's what N is. It's the number of books. Okay, we don't know how many books there are. It's just N. Okay, so what this means is that one publisher releases many books. Okay, so one publisher can release any number of books. Okay, so one too many. That's how we would say it. This relationship, the relationship between publishers and books, is a one-to-many relationship. So what does that mean? What that means is that one publisher can publish many books, okay? But a book can only have one publisher, okay? So that's what this means. A singular book can only have one publisher, but one publisher can publish many books, okay? If there was a 1 on each side, so if it was 1, 1, that would mean that one publisher can only publish one book, and one book can only be published by one publisher. And if it was NN, that would mean many to many, okay? Many to many. So many to many would mean that many publishers can publish many books, and many books can be published by many publishers. Or like one publisher can publish many books, and one book can be published by many publishers. So that would be many to many. But what we have here is one to many, as opposed to one to one or many to many. Okay. Anyway, so yeah, we've got a one to many relationship here. Okay, so this is what the entity relationship diagram looks like. But that's not the database itself, right? That's like a representation of the database. It's like a picture. But once you've got this ERD diagram, guys, like this is the difficult part. Once you've designed this entity relationship diagram, it's very easy to convert it into a database, okay? So all you do is that each entity, okay, so each entity in the ERD diagram, so in our case, the publisher and the book, will get its own table, okay? So we're going to have a table for publishers and a table for books. The next thing is that each attribute under each entity, so for our publisher, ID, name, and city, and for our book, ISBN, title, and author, each attribute will become a column in the table. Okay? And the primary keys are the ones that are underlined, but we'll talk about that now. Okay? And then we map the relationship to the two tables. And what we'll do for that is that if we have a one-to-many relationship, all we're going to do is put the primary key of the publisher inside the book table. But you'll see that now. So step 2 is maybe a little bit weird if you haven't seen it before, but it's quite easy. So I'll jump to the next page. So what we've got here, we've got our ERD diagram. All I did was I added a genre. Okay, so the book now has 4 attributes. It now has a genre as well. And it has an ID instead of an ISBN, just because ISBNs are like 13 characters. I didn't feel like typing out 13 characters. So an ID will just be one number, okay, an integer, basically. Okay, cool. So what we're going to do, we're going to create 2 tables, okay? Okay. A publisher table, and it has 3 columns, you see. So it has 3 columns. It has 1, 2, 3, ID, name, and city. Why does it have 3 columns? Because it's got 3 attributes, right? ID, name, and city. Okay, so that's our publisher table. Okay. Next, we have to create the book table. Now, usually the book table would also have 4 columns, right? It would have a column for the ID, a column for the title, a column for the author, and a column for the genre. But the other thing to remember is that every book also has a publisher, okay? Right? Because a publisher releases the book, okay? So every book also has a publisher. So we're going to add another column to our book table to specify the ID of the publisher, okay? So you see, we've got our book has 5 columns. It has the ID, the title, the author, and the genre. That's cool. But it also has the publisher ID. Okay, that's the ID of the publisher that published this book. Okay, and that's our database. We've now actually created a database. I've inserted some data. So I've specified 3 publishers that exist. Okay, so 3 publishers and 3 books. Okay, so let's try and read this database. And you guys will see that it's fairly simple to read, actually. So we've got 3 books. If we've got 3 books, they're identified by the primary key of the book table. Okay, the primary key of the book table is ID. Okay, ID. The primary key of the publisher table is also ID. So each publisher is uniquely identified by this ID, and each book is uniquely identified by this ID. Okay, and they wouldn't necessarily have to be the same. Okay, here they are 1, 2, 3, but you can picture if we had more books, it would be like 1, 2, 3, 4, but there could still only be 3 publishers, for example. Okay, but you'll see how to read it now. Okay. The other place that ID appears is here. So we've got this publisher ID over here, the ID over here, that uniquely identifies each publisher. This is related to this. Okay, it's related to this ID here. Okay. So these are related. Okay, they're related. So let's see how we read this. Okay, it's actually quite easy to read. If I ask you guys for the title of book 3, I want you to give me the title of book 3. Can one of you do that? The title of book 3. Grimm's Fairy Tales. Exactly, that's correct, Yusuf. So how did we do that? How we did that? We asked for the title of book 3. So which column uniquely identifies the books? It's this one, okay? This one uniquely identifies each book. I'm sorry about my drawing. I don't have a trackpad. There we go. Or I don't have a mouse pad, sorry. Geez, what's going on with the mouse? Yeah, it's bad. Okay, let me just see. Okay, that might do a little bit better. So the ID column uniquely identifies each book. We asked for the title of book 3. So we find book 3 in the table. Book 3, that's that one. And we go to the title of this book. And here it is, Grimm's Fairy Tales. Okay, not bad. Cool. Now, if I ask you for the, let's do this one. Let's say I want now, so this is going to be a little bit more complicated. Which publisher published book 2? Which publisher published book 2? Oh, okay, cool. Penguin ID 3. Hey, nice. Yeah, exactly. So it was 3. I should have asked more specifically, like what was the name of the publisher who published book 2? But yeah, you guys are both correct. So how did we do that? So we're looking for the publisher who published book 2. Yeah, exactly, Yusuf. But no, I get it. You got it the first time when you said 3. I wasn't specific enough. Yeah, I wasn't specific enough. Okay, cool. But we wanted the publisher who published book 2. So how did you guys do that? What we did, We know which column identifies each book. It's this ID column. So we find book 2. We find the publisher ID of book 2 is 3. That allows us to jump to the publisher table. Here, 3. And we get the name of the publisher, which is Penguin. Okay. So you see how to read these, right? It's really not difficult. It's a very straightforward way of representing data. It's a very good way of representing data. And you can start getting to pretty complicated questions. Like if I asked you for the cities, okay, so this is going to be more than one city. I want the cities of publishers who published books that have the genre fiction. So this is a difficult question. I want the cities of any of the publishers. So all of the publishers who have published a book with the genre fiction. What cities do those publishers come from? Okay, yeah, exactly. So that's good. Yeah, Springfield and New York. Springfield and New York. So how did we get that? We've got the genre fiction over here. Okay, genre fiction. So we find all the books with the genre fiction. Okay. We find their publishers. Okay, we've got publisher 1 and we've got publisher 3. Okay. Knowing these two things allows us to jump to the publisher table. We're looking for 3 and 1, and we can get those cities. They are Springfield and New York. I'm not sure if me drawing on this helps really, but you can see how we get to that conclusion. Okay. So that was quite a complicated question, right? Like that's not an easy question. It doesn't have only one answer, but you can see that the table allows us to answer that kind of question very easily, right? Like equally, we could ask, which publisher published a book by Siegfried Sassoon? Again, not too bad of a question because the data is represented in a sensible way. We can find the author Siegfried Sassoon. Okay. We can find the publisher who published the book by Siegfried Sassoon. Publisher 2. We can jump over to 2 and we can see that it's Infogrid Pacific. Okay. So that's that. Cool. So that's how you read a database. Pretty simple. And guys, this is a database. It's just 2 tables. Okay. In this case, you can imagine that a database could have more than 2 tables if it has more than 2 entities. But here we've just got 2 entities and that's our database. Quite simple. Okay. So what's the primary key? The primary key is the column that uniquely identifies each row. So it's the ID of the publisher table and the ID of the book table are our primary keys. Okay, cool. So 2 rows can't have the same primary key unless they have the same data. Okay, cool. Anyway, so that's that. Now, the thing is, so this database looks quite good, right? This database looks quite good. We're able to answer very complicated questions using this database. But actually, this database is very flawed. Okay, it's not a good database. This database is broken in some fundamental ways. Okay, and how we fix the database is we do something called normalization. We perform a process called normalization, and that will fix the database for us. There's just 3 rules that we have to remember to normalize the database, and we just apply those 3 rules in order, and then the database will fix itself. It's almost like magic, except it requires a lot of thinking. So what have we done so far? So creating a mission statement, that's just knowing why you need to define a database. We created an ERD diagram. Okay, we created this entity relationship diagram, which allowed us to automatically solve these middle 4 steps. From that ERD diagram, we're able to determine the data that needs to be stored. We're able to divide the data into tables and columns. So tables and columns, that's entities and attributes. We're able to choose the primary keys. So that's the column that uniquely identifies each row. And we're able to identify the relationships. So these middle 4 steps are all handled by that ERD diagram that we created. The last step is this, to normalize the database. And that's going to resolve a lot of the issues that we have. Okay, normalization, quite a long concept, but we'll get into it now. Okay, so Why do we normalize the database? For two reasons. It protects the data's integrity and it improves the ease of maintenance. Okay, data integrity and ease of maintenance. And the thing that we protect our data integrity from are called anomalies. Okay, anomalies. All right. So that's a very abstract understanding, but we can actually dive into this properly. So what I've got here is our book table. It looks a little bit different, but you guys won't mind. I'm going to change the tables a little bit, just so that you can get used to like some different ideas. Okay. So what I've done with this book table, we no longer have publishers. Okay. We're not thinking about publishers anymore. We now just have genres, but what we've done is added a genre ID. So you can see genre 1 is poetry. Genre 2 is fiction. And you can see we've got 2 fiction here because both of these genres are fiction. So both of them have the same genre ID. Okay. We've got a title and we've got an author. But notice how we're only dealing with one table now. So our database just has one table, just to keep things simple. Okay. Cool. So that's that. We've got that basic thing going there. So the thing is, this table, just like the database we had on the previous page, this table is very broken. Okay, this database is very broken because it would suffer from a lot of anomalies. There are 3 anomalies that we try to protect our database from when performing normalization. 3 different anomalies. Okay, the first anomaly is called an insert anomaly. An insert anomaly. So what this means is you cannot insert new data because some things are unrelated. Okay. So for example, over here, in order to give that example over here, let's say I wanted to add a genre to our table. What I'm going to do, I'm going to click down here. So let's say I wanted to add the genre historical. Okay. Let's say I wanted to add that genre, right? And we would probably call that genre 3, right? This would be genre 3, our third genre. Okay. Ooh, that's fine. Okay, I think we can move it with this, I think. Yeah. So we're adding genre 3 called historical. What problem do you see here, guys? What problem do you see here? And while you do that, I'm going to take off this jersey because it's boiling. All of a sudden. What problem do you see here when I'm trying to add this new genre? Okay. Anyone see a problem? So you can see so far, I don't have any historical books, right? I don't have any historical books. I just want to add the historical genre because like later on, I might add a historical book. But for now, I just want to know that this genre does exist in the world, right? Like nonfiction or biography. I want to have all of these genres available for when I get books with those genres, right? That makes sense. But what problem do we run into here if our database is designed in this way? You notice that in order to insert a genre of type historical, I need to have at least one historical book, right? I need to have a historical book over here, right? Or then the table would be incomplete. You understand? Like I couldn't just have a row without an ID, a title, and an author, and just 3 historical, because that's meaningless. This table is a table of books, okay? So this is called an insert anomaly. When I want to insert some new data, okay, that's perfectly reasonable to want to insert, like a new genre, but I can't insert it because my database is designed in a way that doesn't allow me to insert it. That's called an insert anomaly, okay? So that's the first kind of anomaly. The next kind of anomaly is the delete anomaly. Okay. What happens with the delete anomaly is that when we delete a row or a record from our database, we end up unintentionally deleting another kind of data. So I'll give you an example here. Okay, I'll give you an example. So let's say what we were doing was in one day we were asked, like management came down and they said, okay, please remove the war poems of Siegfried Sassoon from the database. Okay, we no longer have this book. We don't stock this book anymore. It's no longer for sale. Okay, so we delete this from the database. We delete this record from the database. Okay. The following day, they come back to us again, like we're the database administrator at like a major library or something, and they ask us, can you give us a list of all of the genres we've ever had in our database, or of all of the authors that we've ever had in our database? It doesn't matter if we still sell them or not, but we just want a list of all of the authors and all of the genres we've ever had. Do you guys see the problem here? Can one of you tell me the problem? I need more water, I think. Anyone see the problem here, guys? I don't think it's too difficult to see, right? It's that because the author and the genre are stored with the book, even though they're not really directly related to the book, right? When we deleted the war poems of Siegfried Sassoon, we also deleted Siegfried Sassoon and we deleted poetry. Okay, you see that? So when we deleted this book from our database, we also deleted the fact that we once stocked a book by Siegfried Sassoon and that poetry is a genre. We deleted the entire genre of poetry. We no longer even know this genre exists. Okay. And so that's called the deletion anomaly, a deletion anomaly. So that's when you delete some unrelated data. Okay. You try to delete one piece of data, but it has unintended consequences. Okay. The last kind of anomaly is an update anomaly. This occurs when you're updating a piece of data, but because of how your table is structured, when you update that one bit of data, you have to update multiple rows. So even though you're only changing one thing about your database, you end up having to change multiple rows. Okay, so where would this occur in our database? If we were asked one day to change the genre of fiction to literary fiction, okay? So instead of fiction, we wanted literary fiction. So we just wanted to add like literary fiction here, okay? Literary, the word literary, we just wanted to add that there. So that fiction would now be literary fiction. Genre 2 would now be literary fiction, okay? When we make that change, rather than just changing the genre once, right? Rather than just updating the genre, we're going to have to update it in every row of the database. So you can imagine if we have 100,000 books in our database, you can imagine that, and we have like 50,000 fiction books. We would have to go and update this one to literary fiction. We would have to update this one to literary fiction. We would have to go through our whole database and update every single one to literary fiction. Okay, that's obviously a huge mission. If you want to update like one simple piece of information like that, you only want to have to update it in one place, okay? Because that's much easier, it's much quicker. Okay, so that's those are the three anomalies that we can deal with: an insert anomaly, okay, a delete anomaly, an update anomaly. Okay, those are the three anomalies that we can deal with. Okay, hopefully that makes sense. And you can see the examples that I gave are specified inside these blocks. What I did, I think chapter 6 of the book, of the textbook, which I posted on the group, the PDF, is very bad, guys. The book handles this section very badly. So what I did, I included everything in the slides. Okay, you'll be able to study chapter 6 from the slides. You'll notice these slides have a lot of text on them, which I don't usually like, but in this case, it might be helpful for studying. Okay, so you can see we have these problems with the way that our table is currently designed. And the reason our table has these problems is because it is not normalized. This table is not normalized. So what we can do is we can apply the sequence of steps to normalize the table, okay? And that process is called normalization. There's 3 steps or 3 forms or 3 rules that you apply to your table or apply to your database in order to normalize it. Okay. The first normal form, the second normal form, and the third normal form. So what we'll do, we're going to take a break now, but then we'll come back and we'll go through all 3 of the normal forms, and then we will be done for today. Okay. But for now, let's take a 10-minute break until 10 o'clock. And then we'll come back and go through normalization, database normalization. Okay. 10 o'clock. Okay. Cool. I'm going to go get another glass of water and then I'll be back. If you guys have any questions in the meantime, even if they're not strictly related to databases, feel free to post them and I'll answer them. Okay. But yeah, I'll see you guys just now. I'll be back now. Cool. I'm back. But yeah, we're still on break until around 10. Cool. Let's jump in again, guys. Hope you're back. Cool. So we just have to discuss the 3 rules of normalization. So the first one is called the first normal form. Fairly simple name. And so what we're going to do is we're going to take this table over here, this one over here, and we're going to move it through each of the normal forms. So first normal form, second normal form, and third normal form. Okay. So we start with 1NF. So 1NF, the first normal form. And this is the rule. And all of the rules are this simple. It's like a single sentence. Okay. So for a table to be in 1NF, so for a table to be in the first normal form, none of its columns should contain multiple values. Okay. None of its columns should contain multiple values. And what we mean, so this is how they phrase it in the book. I think a better way of thinking about this is that none of its fields or none of its cells. So you guys know what a cell is? It's just like a single place like this, okay? So just a single square, a single block, okay, is a cell or a field, okay? So none of its fields, you can read columns if you want, none of its columns should contain multiple values. Multiple values. So for example, what can I put here? What can I give you an example of? But actually, I think you guys should be able to see. So let me ask you that first. Is this table in 1NF, guys? Is this table in 1NF? For a table to be in 1NF, none of its columns should contain multiple values. Is this table in 1NF? And if not, why? Where does this table have multiple values in a single field, a single cell? Okay. Which cell or which column contains multiple values? So someone says yes. So I'm going to tell you this table is not in 1NF. And it's not in 1NF because of one cell in particular. One particular cell breaks this table's 1NF. Okay. One particular cell. So where can we see multiple values? So hey, yeah, Chris, that's very, very observant. Yeah, nicely done. Maybe a bit of a guess, but no, it's a good intuition. And yes, that is correct. But yeah, maybe it is difficult to see. I don't know. It does. But yeah, I'm impressed. That's cool. But yeah, so you can see here, all of our tables look pretty reasonably like they all contain like one thing, right? Like we've got one ID, right? One ID. And every single row contains one ID, right? Every single row contains one title, okay? Every single row, except one, contains one author. This all contains one genre ID. This all contains one genre. So yeah, it is this one. There's 2 authors in one cell, okay, which breaks first normal form. This is not allowed. Okay? And you can imagine like the multiple ways in which this could break things, right? Like if you had an insert anomaly, right? Like let's say you wanted to go through your table and you wanted to change it so that instead of specifying the entire first name of the author, you just specify the first initial, okay? So this would be like S. Sassoon, F. Kafka, J. Grimm, W. Grimm. You can imagine that when there's 2 authors in one cell, that's going to break things a lot. It makes it extremely complicated to perform that like simple step, right? So that's why we have the first normal form. And yeah, so that's correct. The reason this table is not in first normal form is because of that cell over there that contains 2 authors. So how would we go about fixing this? The simplest way is to just remove the author column from this table. Okay, we remove the author column from this table, and all we do is we throw it down here. Okay, we put it over here. Okay, we create another table called the author table. And inside the author table, so each author has their own ID. Okay, each author has their own ID. They also have a book ID, okay, a book ID. You see over there? And all the book ID says is like, which book did this author write? Which book did this author write? Okay, that's all the book ID is specifying. And so now you can see that if I ask you which authors wrote book 3, you would look for book 3, you would jump over to the book table, the author table, you would find all of the authors in the author table who have written the book with the ID 3, and you would see that it's Wilhelm Grimm and Jacob Grimm. And there we go. Now our problem is solved. Okay. So that's how you would actually create this database. Although this is also, you would then have to, so this would put this table in first normal form and this table in first normal form, but you would then have to go through the next normal forms with each table again. Okay, but we're going to leave the author table for now. You would have to normalize that table as well. Like you would have to take that table to second normal form and third normal form. But for now, we're only normalizing our book table. All we care about is our book table. We're tunnel visioning onto our book table. We're taking it through the normal forms. And then you would go back and normalize all the other tables. Okay. But yeah, anyway. So that puts this table in the first normal form. Because now you can see inside the book table, none of our columns contain multiple values. Okay, cool. So that's the first normal form, a fairly easy one. Like once you know what to look for. And guys, an easy trick here, when you're asked this, an easy trick here is if there's ever a column with a comma in it, if there's ever a comma there, okay, a comma, pretty much. Obviously, if the cell is a sentence, like if it's a sentence that requires a comma, then obviously that's like it's one sentence, so it's not multiple values. But basically, whenever there's a comma separating two separate things, like two separate authors or two separate genres or anything, okay, two products, two prices, two phone numbers, all of that kind of stuff. If there's a comma separating them, then that's multiple values and that's not first normal form. Okay, cool. So that's the easy thing to look for. Just look for a comma. Okay. Anyway, so that's the first normal form. Pretty easy one. The second normal form is slightly more complicated because it requires us to learn about some other concepts or just some other words. Okay, it just requires us to learn about some new words. Okay, so the first thing we need to learn about is functional dependence. Okay, functional dependence. So y being functionally dependent on x means that the value of x uniquely determines the value of y. Okay, so what does that mean? That's what functional dependence means. That's like a mathematical definition, but we can go through it here. So what functional dependence means is that if you know the value of x, then you know the value of y. Okay, so if you know x, then you know y, then y is functionally dependent on x. Okay, that's what it means. So let's see that here. So we can see that if we know the genre ID, okay, if we know the genre ID, I'll ask you two separate questions. Okay. So we're going to say the genre ID is X. Okay, genre ID is X. Genre ID is X. So if we know X, so if we know the genre ID, let's make genre Y. Okay. And I'll ask you this. Is Y, in this case, is Y functionally dependent on X? Is Y functionally dependent on X? By your understanding already, just from the sentence. Yes or no? Is Y functionally dependent on X? And remember, so what I'm asking you is, if we know the value of X, do we know the value of Y in every case? If we know the value of X, do we know the value of Y? No. You think no, Chris? So when don't we? So yeah, this is the first time you've seen this concept, so don't worry about it. Obviously, like it's a pretty complicated idea to be jumping into. But essentially how we would write this is that X implies Y. Okay, X implies Y. And so the answer here is actually yes. Okay, so let me show you. So if we know that X is 1, then we know that Y is poetry. Okay. If we know that X is 2, then we know that Y is fiction. Okay. In every case, do you see that? Whenever X is 2, right, Y is fiction. Whenever X is 1, Y is poetry. Okay. And so we have this functional dependence between X and Y. Okay. Cool. So that's one okay example. But let's see an example where there isn't functional dependence, just to show you the counter of that. So now what I'm going to do, I'm going to make X genre. Okay. And I mean genre ID, sorry. So X can be genre ID. And let's make Y title. Okay. And we're going to ask the question, does X imply Y? So guys, what's the answer? Is Y functionally dependent on X in this case, where X is genre ID and Y is title? This time, do we have functional dependence? So now the answer is now no. Okay, the answer is now no. Why is it no? Because when the genre ID is 1, okay, we know that the title is the war poems of Sigfrid Sassoon. So that's cool. However, when the genre ID is 2, you see over here, when the genre ID is 2, we don't know what the title of the book is. The title could either be Metamorphosis or it could be Grimm's Fairy Tales, right? You see that? So there is no functional dependence here. We don't know. Okay, we don't know. The genre ID does not tell us what the title is. Okay, so there isn't functional dependence here. X does not imply Y. Okay, and you can see that if we made, likewise, if we made Y the ID itself, right? See over here? If we made Y the ID itself, we can ask the question, is Y functionally dependent on X? And you can see that no, it's not, right? If the genre ID is 1, we know that the ID is 1. So that's at least one thing. But if the genre ID is 2, once again, the ID could be either 2 or it could be 3. We don't actually know. We don't know whether it's 3 or 2. Okay. We don't know. If the genre ID is 2, we don't know the ID. It could be either 2 or 3. So the genre ID does not tell us the ID. However, if we flip that around, let's flip it around. Okay, let's flip that around. Let's make the ID X, okay, and the genre ID Y. And now if we ask the question, does X imply Y? The answer is yes, okay? Because we always know now, if the ID is 1, we know that the title is the War Poems of Sigfrid Sassoon, and we know that the genre ID is 1. So whichever one we make Y, it doesn't matter. We could make any column in the table Y. It's always going to be functionally dependent on X. X uniquely determines every single one. If we know the ID, we know the genre. If we know the ID, we know the genre ID. If we know the ID, we know the title, okay? And this is a rule, guys. So in databases, every single column, all of them, every single column in your table will be functionally dependent on the primary key, okay? On the primary key. As long as it's one column. So if the primary key is one column, then every single column in your table will be functionally dependent on the primary key. As a rule, because the primary key, its whole purpose, right? Like you remember what the primary key is? Its whole purpose is that it uniquely determines each row, right? It uniquely determines each record in your table. So it must be, the primary key must be, must have this quality by definition. Every single column must be functionally dependent on the primary key. Okay. But yeah, anyway, so that's functional dependence. And all it's saying, if you know X, you must know Y. Okay, that's what functional dependence means. If when you know X, then you know Y, then you can say that Y is functionally dependent on X. Okay, that's what it means. All right, so hopefully that makes sense. And we'll jump into the next thing now. Okay. Yeah, so I for when you guys are studying later, I've given some examples here. So you can see that everything is functionally dependent on the ID. Okay, so ID, title is functionally dependent on ID, genre ID is functionally dependent on ID, genre is functionally dependent on ID. Also, so we see that title is obviously functionally dependent on ID, but we also have this secondary functional dependence, right? Like genre ID. So genre is functionally dependent on genre ID. And we can see that, right? When genre ID is 1, genre is poetry. When genre ID is 2, genre is fiction. And so, yeah, we've got functional dependence there as well. Okay, cool. So you just have to ask yourself the question, if I know X, do I always know Y? Okay, so basically there mustn't be, if we make ID X and it's 2, there must never be another case. Like if we're asking, is Y with being title? So is title functionally dependent on ID? Currently it is. However, if there was ever another case where we put 2 here, if we put another 2, and in this case, it wasn't metamorphosis. Now, when we put 2, it's actually, let's say with ID2, we had another title that was, I don't know, Lord of the Rings or something, K-Lodder, K-L-O-T-R. Okay. Now it's no longer functionally dependent, because when the ID is 2, we don't know. We don't know what the title is. Okay. If it was still metamorphosis, then that would be okay. Okay, if it was still metamorphosis, so if it was still metamorphosis, picture if I wrote metamorphosis there, if it was still metamorphosis, then it would be fine. We would still have functional dependence. Okay, cool. So hopefully that makes sense to you guys. If it doesn't, feel free to ask any questions you have. But yeah, and let me know. Make sure that I know. Okay, cool. But hopefully that makes sense to you. Okay, so that's functional dependence. Not too bad. The next thing we have to know before we move on to the second normal form is this thing called a composite key. Okay, so a primary key, we've only seen primary keys that are a single column, right? Like ID. We've always had an ID, author ID, you can see is underlined there. We've got ID over here. We had publisher ID. We've always had our primary key being one column specifically, right? However, you can, and you should never do this, but you can create a database where you specify that the primary key is more than one column. And this is just, you can just make this up, okay? You can just say, if I create this database over here, this table, I can say that the primary key is ID and animal ID. That's allowed. I can just make it that way, okay? And then it's called a composite key. Okay, so the primary key is now 2 columns instead of 1 column. All right, which, I mean, you shouldn't have to do this, because you can see that you could hypothetically uniquely identify each row with this over here, right? You could do it that way, but you can just arbitrarily define your primary key to be more than 1 column. And then we call it a composite key. A composite key, composite means that it's made up of multiple different parts, like multiple smaller parts. That's composite. So a composite key, it has multiple columns in the key, okay, in the primary key. So we call it a composite key. Okay. So when you understand these two ideas, functional dependence and a composite key, then you can understand the second normal form. The second normal form. So what is the second normal form? This is the rule. Okay, that's the rule of the second normal form. As I said, it's almost always just like one sentence. So for a table to be in the second normal form, it must be in the first normal form, and all non-key columns must be functionally dependent on the entire primary key. Okay, all non-key columns must be functionally dependent on the entire primary key. That's what second normal form requires. Okay, so this rule looks complicated, and I would say that this is the most difficult of the rules. Actually, I would say this is the most complicated rule, but actually, or it's the most complicated rule to understand at first glance. But once you know it, once you know what the rule is saying, it's very easy. So what makes this rule so easy is that any table all of them, there are no exceptions, any table that is in first normal form, okay? Any table that is in first normal form and has one column in its primary key must be in second normal form, okay? It is in second normal form, okay? So any table, all of them, that is in one first normal form. So what does first normal form mean? It means that it never has multiple values in any of its columns, okay? So none of the columns contain multiple values. So any table that is in first normal form and has only a single column in its primary key is in second normal form, okay? So let's look at this. Here's our table. This table, we made it, it is in first normal form, right? None of its columns contain multiple values, right? None of its columns contain multiple values. So if we go through this rule, for a table to be in 2NF, it must be in 1NF. Okay, so this table is in first normal form. And all of its non-key columns must be functionally dependent on the entire primary key. So that means that ID, that's the primary key, and that's the entire primary key, right? Our entire primary key is ID. It must uniquely determine title, it must uniquely determine genre ID, and it must uniquely determine genre. Okay. But you know it does this by definition. In all tables with a single column as their primary key, every single other column is functionally dependent on the primary key by definition, okay, as we saw previously. And so this table is in second normal form. Why is it in second normal form? Because it's in first normal form and it only has one column in its primary key. Okay, so it's in second normal form. We don't even have to look at it, okay, because it's in first normal form. We know that from the previous step, and it only has one column in its primary key. So it's in second normal form as well. So that's that done. That's second normal form done. So you can see that the rule looks quite confusing, but basically all you have to do is make sure that there's only one column in your primary key. So let's see a case where that's not true. Okay. Let's look at this table. So this table has two columns in its primary key, right? It has two columns in its primary key, these two. Okay. And so we now have to check. We can't automatically assume that this is in first normal form. We have to check. So what is it saying? It says all non-key columns must be functionally dependent on the entire primary key. On the entire primary key. Okay. So I think this is quite similar to the example they gave you in your book. Yeah, over here. Yeah, so we have to check now. Is every single column functionally dependent on the entire primary key? So we can see this. Look, this is quite easy to test. So let's just consider animal ID. Okay, just consider animal ID. Okay, let's just consider animal ID. Is the date column, so we're going to make animal ID X. We have to check, is every single column functionally dependent on the entire primary key? We're going to make animal ID X and we're going to make date Y. Okay. Date Y. Okay. Is the date functionally dependent on animal ID, guys? So is Y functionally dependent on X? You answer this question. I don't want to give you all the answers. So you tell me. Do you think that no, it's not? Okay. Yeah. So can you tell me why, Chris? I don't know. I know it's a lot to type. Although really you would have to type 4 things, right? 4 things. The values of each of the rows that make it so that this can't be functionally dependent. Or like, can we say, let me ask you this. Which animal ID? Yeah, exactly. Dates has 2. That's the best way of putting it. Yeah, exactly. So dates has 2 different values for the same animal ID, right? If we know that the animal ID is 1, we don't know whether the date is this, like the 28th of September or the 5th of October. We don't know. It could be either date. Okay. And so we can see that immediately the rule is broken, right? all non-key columns must be functionally dependent on the entire primary key. It's already not true. Date is not functionally dependent on the entire primary key. It's only functionally dependent on ID. Okay, it's only functionally dependent on ID. Okay. And the same is true. So like so that's that. Okay. So here we know that this is not in second normal form. The easiest way to make it in second normal form actually is to just remove animal ID. Okay, just remove it, or just remove animal. Okay, that wouldn't. No, that's. Oh yeah. Okay, this is the big thing. That animal ID is no longer in the primary key. Okay, you see it's no longer underlined. You see it's no longer underlined. Okay, so there's quite a few ways you can correct this. You could either just remove animal ID from the table, or you can pretend that we moved animal name to another table, and now animal ID is just no longer in the primary key. Okay, you see it's no longer underlined. It's no longer in the primary key. Okay, and so there we go. That would make this then in 2NF. But there's quite a few different ways to do it. But the big thing is, when you're looking for 2NF, all you have to check is there a single column in your primary key? If there's not, then you must continue looking. But if there is only a single column in your primary key, then you already know it's in 2NF, and you can just move on to 3NF. Okay, and 3NF is the last one. This one's actually quite simple, I think. It's not too bad. I think 2NF is the hardest maybe to wrap your head around. This one's pretty okay. So for third normal form, for a table to be in 3NF, it must be in 2NF, and there must be no functional dependence between non-key attributes. Okay, so before we dive into this more, what I want to point out to you is that you can see that each normal form references the previous normal form. Okay, so in 1NF, we have, for a table to be in 1NF, none of its columns should contain multiple values. Okay, for second normal form, we don't just have the rule, right? The first part of the rule is that it must be in 1NF. Okay, so it mustn't contain multiple values in any of its columns. And all of its non-key columns must be functionally dependent on the entire primary key. Then it's in 2NF. Likewise, with 3NF, okay, it must be in 2NF. So what does that mean? It must be in 2NF. That means all of its non-key columns must be functionally dependent on the entire primary key, and it mustn't contain multiple values in any of its columns. Then it's in 2NF. Exactly. So you see, for it to be in 3NF, it must be in 2NF, which means that it must also be in 1NF. Okay, so you can see that it always references the previous one. Okay, so for it to be in 3NF, it must be in 1NF, it must be in 2NF, or rather you can just say it must be in 2NF, because for it to be in 2NF, it must be in 1NF, right? So for it to be in 3NF, it must be in 2NF, which means it must also be in 1NF. Okay, so every single step implies the previous step as well. Okay, so that's one thing to remember as well. Okay, but yeah, so for a table to be in 3NF, it must be in 2NF. Okay, and there must be no functional dependence between non-key attributes. Okay, so that's the next part of the rule. So when we look at our table, we know this table, it's in 1NF, right? It doesn't contain multiple values in any of its columns. It's also in 2NF. We know it's in 2NF because it only has a single column in its primary key. The primary key is just ID. Okay, so we know it's in 2NF as well. And so now we just have to check, is it in 3NF? And all we have to ask here, between any of our non-key attributes, so what does that mean? All of our non-key attributes are title, genre ID, and genre, right? Because ID is our key attribute. This is our key. Okay, it's just ID. Our key is just ID. So our non-key attributes are title, genre, ID, and genre. And all you have to ask, is there functional dependence between our non-key attributes? Is there functional dependence between our non-key attributes? So can you guys answer that question? Do we have any functional dependence between our non-key attributes? Yes. Okay, where's the most obvious one, Chris? Where's the most obvious functional dependence between our non-key attributes? Exactly. What is functionally dependent on genre ID? which column is functionally dependent on genre ID in our non-key? I mean, you know the answer, so I won't. You know that genre is functionally dependent on genre. Exactly, yeah. So we know that genre ID. Oh, sorry, I'm not drawing anymore for some reason. Oh, there we go. We know that genre ID implies genre. Okay, like that. Okay, so genre is functionally dependent on genre ID. Okay, cool. And so that means this table is not in 3NF. Okay, so how do we make it in 3NF? All we have to do, similar to what we did previously, we split it up again. Okay, so we're going to make our book table contain ID, title, and genre ID. And all we're going to do is say, okay, genre is this separate table over here. Okay, like this. And so now our problem is solved. Now you can, the very sort of astute observer might go that technically title does uniquely determine genre ID. But what I want to tell you is that obviously you could picture, if we were working with the table, it requires some intuition, right? Like you can imagine a situation where there are two titles that are the same, okay, but in a different genre. Okay, so like you have to use your intuition a little bit. Like obviously the title is not going to be a key. Okay, like in this case, you might consider it that, but there is some intuition involved. Okay, but like so this is a perfectly reasonable split here. Okay, cool. But anyway, so the main thing here is that now genre is in a separate table, and you can see this now solves all of our problems. We've solved our problems, right? Like our deletion anomaly. If we delete the war poems of Siegfried Sassoon from the table, it doesn't matter. We still know poetry exists as a genre. We still know that poetry exists. So that's okay. The deletion anomaly is fixed. If our insertion anomaly, if we wanted to add the historical genre, we can just do that. We can just put a 3 here and we can make this historical, okay, history. Okay, so our insertion anomaly is fixed. Okay. Our update anomaly, if we want to update fiction to literary fiction, we just have to update this one cell over here. We just have to change this to literary fiction. And then all of our books with genre ID 2 will automatically know that the new genre is literary fiction. It's no longer fiction. But we only have to update one cell. We just have to update this cell over here to literary fiction. So that fixes our update anomaly as well. So all of our anomalies are fixed and our database is in 3NF. So we've now ensured our data integrity and ease of maintenance. Okay. Cool. So that's all of the terminology that I have to introduce you guys to for databases. I see we're very early. You guys worked through this quite quickly. I think it's easier because it's a smaller class, so there's fewer like questions and stuff. But yeah, so that is that. I mean, there's one more thing that I do want to show you, and we would have done the chapter 5 Mentimeter quiz, but the problem is attendance just is too bad for us to do it. So that's the problem. But I can show you one other thing. Let me just get it open. I'll post it on the WhatsApp group as well. Okay. But let me just open it quickly here. So I just need to log into my WhatsApp. So I'm just going to stop sharing my screen a little bit. Sorry, guys. It'll be a second. Cool. Let me find it quickly. Okay, here it is. Okay. Okay, so there's going to be a URL that I'm going to post on the WhatsApp group. Okay, let me just... Okay, after the lecture, like when I upload the video and stuff, and all that's going to show you, let me just share my screen. Okay, is this. It's going to bring you to this thing over here. So this is like a, it's almost like it'll cover everything we covered in today's lecture in slightly more detail, okay? So you'll arrive at this page. It's like Tembi needs your help Tembi develop her database for a social media app she is designing. You'll hit begin course, check it out, cool. So this is it. And you'll just work through. So you'll just work through. There's like a couple of pages. So we'll submit the survey over here. Cool, I'm excited, great stuff. and you can go through each of these pages, okay? And you just hit next, 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 next. And it won't take you too long to work through. There's lots of videos, okay? There's lots of videos to add extra content. They're not too long, like the videos aren't too long. But if you're super confident on a particular part of databases already, then you don't have to watch every single video. So only watch the videos that you feel like will help you, and make sure you answer each of these quizzes. Okay, so what is a database? Where do we need one? So you can see, like, you can look through a couple of examples and you can see like what is data. So here's a question, right? So I'll answer this one to give you guys an example. So what is data? Drag and drop each of the below statements into the correct boxes. Okay, so your name, age, height, weight, etc. are some data related to you. I think so. That's data. Your phone, your TV, your house, the product you purchased, the product price, the product code are some data related to your transaction. That seems data are pieces of facts contained inside a database. That seems right. Your phone, your TV, and your house. I might say not data. Okay, cool. So I got that right. So there we go. So you see, like your phone, your TV, and your house, they're actual like physical things in the real world. Like my house is not a piece of data. Like my address is a piece of data. With like, yeah, like the price of the house is a piece of data, but the house itself is not data, right? It's a house. But you can see that these are all examples of data. Data are the pieces of facts contained inside a database, the product you purchase. So there we go. That was a question. We would go through the next question and the next question and then hit to the next page. Okay. And you'll just go through it like that. And it'll just give you an even better understanding of what we went through today. Okay. So yeah, I'm going to share this with you guys, and please work through it before next weekend's lecture. I know a lot of you guys are going to be working hard on exams and stuff, but this one, it shouldn't take you too long. It'll be like 40 minutes maybe. And it's quite fun as well. Like it's nice, it's interactive. You'll learn a lot. So please work through it before next weekend's lecture. Okay. And if you're watching on YouTube, then please work through it before you watch next week's lecture on YouTube as well. Okay. Cool. So that is that for this week, guys. I know we finished a little bit early, but so now you've got 20 minutes of lecture time where you hypothetically could work on tech roads. So take that 20 minutes and budget it sometime into the week, okay, to work on that URL that I send you, okay. A lot of effort went into designing those things, so please do give it a try, okay, and work through it. But yeah, that's it for this week, guys. See you next week, and yeah, bye, Yusuf. Enjoy your weekend, eh? Thank you for coming. Cheers, Chris. Enjoy your weekend. And yeah, I'll see you guys next weekend. Next weekend, I think we will probably use our full time. But yeah, we'll see. But yeah, cool, guys. Bye.